Hey, what's going on, folks? It's Mike here, and welcome back to my Deprogramming Language series. In today's episode, we're going to continue looking at ranges and discussing what exactly a range is and what types of ranges we can use with for each loops. So with that said, let's go ahead and take a look at the Deprogramming Language website here. And I'm going to go to the documentation and down to the library reference here. And there's going to be a few helpful things to take a look at. Now, if you didn't see the previous video where we just sort of explored ranges, that could be useful here. We'll see all the different functions that we have available, and I'll do a quick little review here just so we have an idea of how we use some of these range functions. But again, this is going to be useful. But otherwise, we're going to want to take a look at some of the range primitives and even the range interfaces here just to understand what a Phobos, again, we're in the standard library, range is versus other types of ranges that we have here. Okay, so let's just do a little bit of a review here. And again, I've included the standard range library here just so we can see what we have available if I want to write some sort of for each loop. Now, last time we found out that what I can do is create some sort of dynamic array here, something like this here. Let's just call it data 1, 2, 3, 4, 5, 6, something of the sorts like that. And then we'll just want to use that for each loop to iterate through each of the elements here. So I'm just going to go ahead and proceed forward to write out each of the elements. And let's just go ahead and write this out, and we see it works just fine here. Now, we also saw something that was kind of interesting here, where if I created a static array here, let's just call this static or fixed size array here. Let's call it fixed size array. Fixed size array. And let's assign it some elements here. And I'm going to do basically the same pattern with the for each loop here. And try the fixed size array. And write out every element here. That this works fine, just as expected here. But the trick is, if we want to use some of our range functions that we have here, like take, for instance, to maybe just take the first two elements. We can run this, and it works just fine here. It takes the first two elements. But if I try to run this here and take the first two elements, we get a bunch of errors here. Now, why is this? Well, if we look through this error message here, it's going to say no property take for fixed size array of type, well, our fixed size array type here, because the template take is not callable using arguments, and it provides us the arguments here. And ultimately, it's going to tell us the template constraint here that says this thing needs to be an input range. So, okay, we've kind of uncovered some of the mystery as to why this doesn't work. This is clearly different than this here for the input range, or otherwise we don't have a way to sort of convert, at least implicitly, this fixed size array thing to whatever this input range is, which we're going to discover today. But there is a fix, don't worry. We can do something like .array, which you'll see all the time in decode here. And now this works here. So this array function here, which is part of range, let's go ahead and take a look at it here. Let's find array. Let's see here if we could find the top, or it might be in std array here, but either way, we've got access to it. Let's see if we can find exactly where that shows up here. Standard array. Is it part of array here? It might be. Yeah, .array returns a copy of the input in a newly allocated dynamic array here. Okay, so we get our dynamic array. And again, it's making a copy of it, so we might want to think later on about the expense here of this. And there's other things here like associative arrays and so on that we could use in this library. But anyways, this will do the trick for us here. Now, what I want to do here is just show you using the compiler first and foremost what is actually happening when we have this for each loop here. Because again, for each can do some interesting things here. I'm going to just demonstrate one other type of loop here. Let's just do for each. And again, I'll just do elements here. And I can have, I don't know, something like 1 to 4. This is another way that I could have written things out. And that'll also work as well, giving us 1, 2, and 3, so not inclusive of 4. And then the first two elements of here, 1 and 2, 1 and 2. And then the first two elements here, 1 of 2. But again, we're using array here to get a copy, or rather make a copy of this fixed size array into a dynamic array here. Okay, so let's just play around with this a little bit just so we can understand this example here. And I'm going to use the decompiler actually for this in VCG for, I believe, call graph. And V is just the sort of output, and I want the abstract syntax tree here. And let's just go ahead and compile that here. and I'll get a few different files here. And I've shown this flag before. This is in the one of the options here. I'll just go ahead and bring in it here from run.dlang.io. So if you want to check out that video and see where we explored online here, for some reason it's not working in your compiler, but basically it gives me this file here, main.d.cg. And let's go ahead and look at that here, this file. And basically what you're going to see here is it has the lowering of how it transforms this loop here into actual code that D understands here. So interestingly, this is sort of a numbers range here, 1 through 4. And we can see that first loop here. Key 40, which again is just the compiler sort of transforming this, and I guess a limit here, for 1, whatever these keys are here, is basically just transforming this into a regular for loop. Again, that's all a for each loop is here. And you can see it's using these values here, and it's added in the scope operations for us. But ultimately, it's writing out the element here. Now, if I scroll down a little bit here, let's take a look at this code block here, which corresponds to, let's go ahead and highlight over here, these two, or these 3 lines here, where basically with take here, what it's doing is, again, with this dynamic array here, we know our length, okay, because we want to iterate through some amount here. We know again, the length we know from this take function here, which knows how to work with a dynamic array here. Again, we basically just do the same transformation here. Okay, so I'm getting, again, the element here from this array. You can see the brackets here, meaning I'm accessing some element in our original array, or this range that we have taken from, those 2 elements here. And now our fixed size array with this take here is doing something similar. Now it's doing the array conversion, and I'll have to disappear a little bit just so you can see around me. Let me delete myself here. There I go. But basically you can see that function call being done here. Now again, you'll notice in D we have the uniform function call syntax, so we can just use dot. But again, the compiler is just transforming that to the correct sort of function calls for us before it generates the code here. So, you know, again, nothing really crazy there, but again, we can see the transformation here. Okay, so anyways, this is all kind of interesting stuff because we can now hopefully see a little bit that for each is just syntactic sugar here. And again, syntactic sugar telling us something about what are the types of forms that basically make a for each loop work. So we can iterate through it here in some sort of range. Now, take, for instance, once we have it in a valid form, which at the very least we know is a dynamic array, whether we have to convert it using .array explicitly or just using a dynamic array like shown here on line 10, will work with for each because it conforms to or has the ability to work as an input range. Okay, so what is an input range? Let's go ahead and take a look here at some of these help pages that I opened up here. Again, from the Phobos standard library here, I open up these 2 files. Let's see, primitives. Okay, is input range. Okay, so this is just going to tell us if we have an input range or not. And then I have my interfaces for what actually is an input range. So again, let's just do some coding experiments here. Let's just try this out here. Let's just say is, and we'll write out here. Let's go ahead and put a few write lines here just to get our output nicely formatted here. I'll close this file out here. There we go here, and let's just go ahead and run it here. Okay, so we can see our 3 examples here. And let's just write out is input range, and then I got to put it in a template here, I believe, the type. Okay, and let's give ourselves a little bit of debug here just so we can see here is input range. And let's make sure that we can have a little colon here just to see if it's working, or rather make it easy for us to read if this is working or acting as an input range. Okay, so this one is true. Okay, so it has its, or it's conforming to is input range here. Let's go ahead with our next one here with the fixed size loop here. So let's change this around here, put a 4. Okay, RDMD, and we do get false here. Okay, so now we at least have a tool to introspect to see if our type here conforms to whatever something is an input range. That means that I can use these functions like take in all of the standard range library. Okay. So that kind of answers one of these questions about, static library isn't input range. I mean, we could just see it by definition. But what would make something an input range? And for that, we should explore the interfaces. So we should see what is an input range here. So this is the wrapper for the interface. Let's go ahead and just click on it here. And basically what it says here, if I look at input range here, let's see here. Let me see if it gives us a clear definition. Or I should say it gives us a few hints here. Let me just go to the primitives here. Here, I'll just go to the actual function. This will give us a clear picture here. It says, okay, return true if R, so that's our type that we passed in here, is an input range. Any input range must define the primitives empty, pop front, and front. Okay, so the following code should compile for any range here. So if I've got some range here, it should basically what D is doing at compile time is it's checking if I can call r.empty, r.popFront, and r.front. Okay, if I have these three functions here, empty, pop front, and front, that means it's an input range. Okay, so let's actually try to play around with and define some structure that has these three functions here. And what I'm going to go ahead and do here is let's just create something here. Let's just call it my range. And again, I need to define these functions here. Empty returns true or false if it is empty, whatever our collection is. We need the front element here. And again, the type is, I'm just going to play around with integers here, but it returns the front for us. And then we'll have a function called popFront that sort of iterates us forward. Okay, so that's the idea of this range object. Okay, so front, we're able to get the front element, pop front to remove an element, and empty. Okay, and we can see the descriptions here. Returns false if and only if there's no more data available in the range. So again, and this is opening up some interesting ideas to what ranges are again, that they could be infinite, right? We could keep adding things to the range or generating more things in the range until we're empty. So that's kind of an interesting idea. Front, again, just the current element. So this would be the element, for instance, in a for each loop that you're looking at. And pop front advances to the next element. It doesn't necessarily have to deal with anything like removing or deleting an object. I guess that could be part of the range functionality. But again, it just advances to the next element in the range. Okay, so let's go ahead and just, as an example here, I'm just going to do like a really simple range type of thing here where I have some counter. And I'll start it at 0. Let's start it at 10 here, just to make it interesting. And we'll say we're empty, return if counter is less than or equal to 0. The front element is just going to be whatever the counter is. Okay, so let's just return the counter value. And pop front, the advancement that it's going to do here is just going to reduce counter, okay, by 1 here. Okay, so something like this. Okay, so let's go ahead and comment out what we have previously here. But let's go ahead and just do a little check to see if this collection that I have here, my range, is an input range. Okay, my range. Let's go ahead and see if it compiles here. My range. Okay, so let's clear that. Give it a run here. And it says it's true. Why? Well, it defines empty, returning a Boolean value, front, just some function where I can call the range on front, and again, some function where I could call my range on pop front. Okay, the return type doesn't matter so much here, but again, we're working with integers for this particular example. And if I deleted one of these functions here, now it's false. Okay, so we're again just checking to see if we adhere to some interface here. So now let's actually use it here. Okay, let's do a for each. And what I want to actually do here, let's create my range. I'm just going to call R, and the element in our R here, let's just write it out here. Okay, let's see what this code does here. And let's save it. Okay. All right, what's it do? Well, whenever I create an instance of my range, right, it creates this counter. It's going to, well, have the counter at 10 here. And then what am I doing here? Well, it looks like I'm I am doing my sort of countdown here. 10, 9, 8, 7, 6, all the way to 1 until I'm empty, when the counter is less than or equal to 0. Okay? So this is kind of peculiar, and to understand this, I think we need to just do a little investigation here by, again, seeing what the code's actually lowered to. Meaning, what's going on in this for each? How do I build a range object? Or in other languages, this is kind of similar if you're coming from a C++ world to having iterators. Okay, so let's look at the main.d.cg file here. And what you'll see here, again with my range here, and the for loop, same or very similar experiment that we did before, you'll see that our for each loop is being lowered into this thing here, where we have our range here. We make our copy of the range here. And then our for loop, no initial condition, right? Because we have all the state that we need in our range object. And we say, okay, while we're not empty, while this condition's not true, pop front. And then we just keep popping an element every iteration of this loop, which executes this code, minusing our counter. Okay, and then what we do at the start of each loop is we get our front element, right? That's what element is initialized to, which is, well, what we return from front. And we can see it on this side here. Okay, so you might need to stare at this a little bit here, but all this loop is just a transformation here. Okay, which is pretty neat here. So in this video, we'll have talked about most of the different ways to sort of iterate, whether with just numbers, using ranges, or otherwise just iterating through a dynamic array. And then we do have to talk about something else called op-apply, which some of you might have seen. That's another way that we can do iteration. But otherwise, this is just another transformation. Okay, so if I want to write a range, which is in D how we sort of iterate through collections of things, right? This is the interface that I need to adhere to. And this is what is known as an input range. Okay, now you might have noticed here, if I go back a little bit, there are other types of ranges: output ranges, forward ranges, bidirectional ranges, and random access ranges. Okay, so interestingly, what we could do here is let's try to see, just as a little experiment here, let's actually bring in some of our code back here, and let's look at just the dynamic array, because that one's kind of interesting here. Let's see if it's also in output range. Okay, whatever that happens to be, we gotta learn more about it. And let's see if it's a random access range. Okay, is random access range. Okay, make sure I spell all these things right. Random access range. Okay, let's go ahead and close this off. Let's go ahead and give this another run here. Let's see here. Is output range. Let's see if I spelled everything right. Right, is output range. I need to add in one parameter here for the type here. Int, it looks like. All right, well, that works here. So if I have a collection of ints, it looks like I can output another int here. And it is true. I mean, intuitively, I've got a dynamic array, which is a random access data structure. So it looks like it also adheres to that property as well. So we'll see how to define these and what the actual interfaces are, or you can go ahead and peek ahead of time if you want to see how to actually make these. But the most common thing that you're going to do here is want to have an input range, so something that you can iterate through by having empty front and pop front, just as we have shown here. Now, just as a little aside here, because we'll end this video because it's getting a little bit long here, I went into the GitHub Phobos library here, which again, the source code is very, very easy to explore, so I'd encourage you to do that, right? Just go into standard and then go into range, and then we'll explore the package. And if I just search for take here, which is a function that we've been looking at, and I'll put the exclamation after it just so we can find it quickly here. Let's just take a look here at some of the actual code here. So if we are defining for take here, similar to my range, this is what we do here. Now you'll notice I have this sort of function here. It's got a template constraint on it that says, okay, it must be an input range. Otherwise we can't take from it, right? And we saw that below here. Let's go ahead and scroll down here. Let me keep my terminal window available for you. There we go. But what we saw is that, again, with our dynamic arrays, they conform to this sort of interface here. But before, we needed to do the dot array here to make sure that, again, we can make this function call if it is an input range. Okay, and it's going to do a couple static checks here, basically, but ultimately, then it'll call the take function, or rather return the take range here, which I believe if I scroll around here, let's see if I can find take. I might need to find the struct take, which let me search for it here. There it is. And then we can actually see what's going on here in this struct take. Let's just gonna move this over here. Very, very similar to if I scroll up here, we had my range. Okay. Now the only thing that we did that was different here is I didn't have a my range function that took in a valid input range, right? Maybe some parameter here, and then I would need to write a little constraint here that says if r is input range r, something like this. Basically, that's what we haven't done here. But here's the actual struct for take here. Again, making sure it's an input range and so on. And then you can see the actual implementation here. There is empty, there is front, and there is pop front here as well. Okay, so hopefully that you can see that that is what is available for take and working with input ranges. And it's worth just staring a little bit at the Phobos code here. But again, hopefully that gives you a little bit of an intuition as to what is going on here in the Phobos library here with our standard ranges. Okay, so standard ranges work on things that are input ranges. We learned how to check based off of the input range interfaces whether or not something is an input range. And ultimately, we saw how that's defined is basically by having empty front and pop front. And that helped answer the question as to, it doesn't really make sense to pop necessarily from a fixed size array versus a dynamic size array. It does make sense to sort of like pop and move forward. And in other words, too, it also doesn't really make sense to say a fixed size array is empty in any sort of sense because, when is it going to be empty? I mean, we're not shrinking this thing. It's always going to be 4 elements. So again, hopefully that gives some intuition about why we couldn't initially use this. But we can use with a dynamic array, which is something that can resize and that we can move it as a input range here, okay, which we've seen always, and we've been able to use things like on our dynamic arrays, take as shown here. Okay. All right. So quite a bit, but again, hopefully gives you a little bit of intuition if you want to start writing your own custom ranges, which we also did. I showed you how to make our little range here with counter 10. And if we wanted to make this work in a more Phobos-like way, we would, define our struct here, maybe provide some constraints here, and then a function that would just return the range for us. That tends to be how things are done in Phobos. All right, folks, so we're going to continue talking about ranges some more. Don't worry, we're not quite done with them. And again, if you haven't seen the previous range videos, check them out on courses.mshow.io or on the playlist that you're already watching if you're on YouTube. But this is a way that you can track your progress otherwise. And otherwise, folks, I hope you've been enjoying this series. I'll look forward to your comments if you've written any cool ranges, input ranges, random access ranges that are not in Phobos. I'd be curious to hear what those are. Maybe they should be things that are added. Maybe they're useful things you've seen in other programming languages. I'd be very, very curious. Otherwise, let me know if I can clear up anything, and I'll look forward to otherwise seeing you in the next video.